Today we're going to cover Chapter 7, Section 2. Today we're going to be covering properties of parallelograms. So the first thing we're going to do is define what a parallelogram is. And a parallelogram is a quadrilateral with two pairs of parallel sides. That's what makes the quadrilateral a parallelogram. When we're writing out a name or trying to name a parallelogram, you either need to take the time and write out the word parallelogram, or what you could do is draw a little picture in front of the four vertices of the parallelogram. So notice in the picture, it's color-coded for us. Notice side BC here has the double arrows, and it's in blue, and it's parallel to AD. That's the first set of parallel lines or parallel sides. And then the other set is AB being parallel to CD. So as soon as you're given a statement like this, showing that AB is parallel to CD and BC is parallel to DA, you can tell that this quadrilateral is a parallelogram by using the definition. Now, when you go to name the parallelogram, you don't necessarily have to put the vertices in alphabetical order. You can choose to start from any vertice you want, but you do have to go around the edges in order. So for example, let's say I start at vertice D here, and let's say I want to name it and I want to go backwards of what's written here instead of going like clockwise. You could go in this order, D to C to B to A. Just make sure that you go around the edges and just pick a starting point. Again, if you want to put it alphabetically, let's say you wanted to start at A, and that's what I had listed there, then from there I went to A to B to C to D. I can't just jumble up the letters. It has to go around the edges in order. Now, also remember that these arrows that are on the sides here, these are not congruency marks yet. These are parallel marks. And that's all we use for the definition, is that it has two pairs of parallel sides. However, on the next slide, we're going to see a theorem, and that theorem is going to show us that opposite sides are congruent. But again, remember, the arrows are indicating that they're parallel, not that they're congruent. The first two theorems, and again, do not memorize the numbers. You're going to either memorize the name or what the theorem states. And the first one is called the parallelogram opposite sides theorem. And what this one states is that if a quadrilateral is a parallelogram, then its opposite sides are congruent. Now, in the picture, that's the hypothesis. So it's a parallelogram, and then you can conclude that the opposite sides are congruent. So we could also, in addition to showing those arrows, we could also indicate that AB is congruent to CD and that BC is congruent to AD, because opposite sides are congruent when it's a parallelogram. Then the next theorem is called the parallelogram opposite angles theorem. And this one states that if a quadrilateral is a parallelogram, then its opposite angles are congruent. And notice it's color-coded for us. And we can see that angle A, which is directly opposite to it, is angle C. These two angles are congruent if it's a parallelogram. And then the same for B and D. So these are officially presented as theorems, but they're also properties of a parallelogram. The next theorem is called the parallelogram consecutive angles theorem. And this one states that if a quadrilateral is a parallelogram, and that's what's under the hypothesis, it's a picture of a parallelogram, then its consecutive angles are supplementary. So we're bringing back chapter 3 with our alternate interior angles, our consecutive interior angles, and this is really what they're saying here. that these are going to be consecutive interior angles. Because if you think about it, you've got your parallel lines here, and then if you use AB as a transversal, then that would make A and B supplementary. And you can keep going around and doing this all the way throughout the parallelogram, because I could do it over on this side as well, using CD as a transversal, making angle C and D supplementary. And then if I use the different parallels and then use BC as a transversal or AD, I've got all of these pairs of supplementary angles. So the word consecutive means in order or right after each other. So notice angle B, and then the one right next to it or right after it is C, and those would be a pair of supplements. Or if you started with A and went to B, that's also another pair of supplements. So we also saw this in chapter 3. Instead of the word consecutive interior, they also name these as same side interior angles. And if you think about it, these angles are on this same side, A and B together, or A and D together are supplements, or C and D, or B and C. So we're using the parallel lines and then one of the other pair as transversals. The next one is called the parallelogram diagonals theorem, and this one states that if a quadrilateral is a parallelogram, then its diagonals bisect each other. Now, this theorem isn't telling us that the diagonals are congruent. It tells us that they're being bisected. So notice they've got Z in here. So that's creating BZ, which is congruent to DZ. And then it also has AZ, which is congruent to CZ, because the diagonals have been bisected. Now, in the homework tonight, they're going to ask you to find the point of intersection of the diagonals. Now, if you think about this logically, the diagonals are bisected. So point Z here is actually the midpoint of the diagonals. So when it asks you to find the point of intersection, all you need to do is calculate the midpoint of one of the diagonals. It doesn't matter which. And you're going to be given ordered pairs. This would be something that would be graphed in a coordinate plane. So we're going to be bringing back the midpoint formula. And if you've forgotten that, remember it's x1 plus x2 divide by 2, y1 plus y2 divide by 2. This is your midpoint formula. And pick one of the diagonals. It doesn't matter which. If you decide to calculate the midpoint for both, you should get the same answer. And that is your point of intersection. So in this particular example, in order to answer these questions, you would need to first be given that ABCD is a parallelogram. So because ABCD is a parallelogram, I can tell that this side AB is parallel to CD. And that's going to answer number 1. And then also what I need to state is that BC is parallel to AD. And this is the definition of a parallelogram. So I'm going to state that AB is parallel to DC. And again, the order of the letters doesn't matter. And BC is parallel to AD. And this is the definition. A quadrilateral with two pairs of parallel sides is a parallelogram. Now, for part 2, it wants me to name all pairs of congruent angles. I got a lot. So let me go ahead and do number 3 first, and then I'm going to go back and do number 2. And I'm going to have to redraw the picture a couple times because once I start adding in these congruency marks, it's going to be a lot. So let's go ahead and do number 3 first. So what I'm going to be using, so in order to answer number 1, this was the definition. Now to answer number 3, I'm going to use one of the theorems that I just covered, and to find the congruent segments, I can use my parallelogram opposite sides theorem. And I can state that AB is congruent to CD using this theorem. I can also state that BC is congruent to AD. And this is using the parallelogram opposite sides theorem. Now I also have congruent segments on my diagonals. So the next thing I'm going to use is my parallelogram diagonals theorem. And here I can state that BE is congruent to DE. And again, the order doesn't matter. You could also say ED. And then also the other diagonal was bisected. So AE is congruent to CE. So those are the 2 theorems I'm using to justify those congruent segments. Now on to number 2. Now for number 2, I'm going to be using my parallelogram opposite angles theorem. So I'm going to use the original picture still. So this is now the answer to number 2. So for the first set, I'm going to do the parallelogram opposite angles theorem. And now that I've got diagonals drawn in there, I can't just say B and D are congruent and A and C. I actually have to name them with 3 letters now. So I can show that this angle up here, A, B, C, is congruent to this one down here, and this could be ADC. And this is using the opposite angles theorem. Then I could also show this one here and this one here. So angle BAD is congruent to angle BCD. Now, you could have gone in the other direction. You could have said DCB, but just know that A and C need to be the middle letters, and then here, B and D needed to be the middle letters. So that's the first pair. The next set are my vertical angles that are around that diagonal. And I'll use the same picture, but when I get to the alternate interior angles that I'm going to show, I'm going to redraw the figure. So I've got this one, and I've already used that symbol, so let's go with 3. So 3 little congruency marks, and then these have 4. So I've got 2 sets of congruent vertical angles. So the vertical angles that are around that midpoint E, I can state that angle BEC is congruent to angle AED. And then the ones on the sides, the AEB is congruent to the DEC. Now I'm going to redraw the picture for the alternate interior. So Let me just draw another parallelogram here. So this is still the answer to number 2. So if I draw another parallelogram here, and I've got B, A, I'm doing the same letters, and then draw in the diagonals. So we need the diagonals for this. So now, since I have parallel lines here with AB parallel to CD, if I use AC as a transversal, since these are parallel, then I can see that I have congruent alternate interior angles here. So now my alternate interior angles that are congruent is going to be angle BAC is congruent to angle DCA. Then if I use the same parallels, but now let's use BD as the transversal. Now it makes angles right here that are congruent. So then now what I can state is that angle ABD is congruent to angle CDB. And these are alternate interior. And that's using the A and the B, AB and CD as being parallel. Now I'm going to do the other parallels, and let me go ahead and redraw this, I guess. It'll be better. So B, A, C, D. Now we're going to use BC being parallel to AD. And again, same transversals. So I got AC as a transversal, but now that's creating this angle congruent to this one. And again, you have to name these with 3 letters. So angle BCA is congruent to angle DAC. And then if I use the other diagonal as a transversal, then that's going to create an angle right here that is congruent to this one here. So angle CBD is congruent to angle ADB. So lots of congruent angles in this picture. So all of these, all of these are parallelograms. Now C, it was missing the vertices. So let me add in the RST. So R, S, T, and U. Also in the first picture, let me add in an A here. It didn't have a variable A. So it wants me to find what A, B, X, and Y are. And this is what you're doing in the homework. Now, some of them are pretty simple like this. And if it does involve any kind of calculations, especially if there's supplements, show me how you're subtracting it from 180. So for the first one, in order to find the measure of angle A, side length A, notice because it's a parallelogram, I just learned a theorem that stated that opposite sides are congruent. So since RS is 6, so is UT, and that's where I put the variable A. So A is 6. Same thing's going to happen for B. Since B is the opposite side to the 9, RU is 9, so is ST. So B equals 9. And then if I wanted to use my opposite angles theorem, I could show that angle U and angle S are congruent using the parallelogram opposite angles theorem. So X would be 80 degrees. Now notice in the picture, you notice how X and Y have the little degree symbol. So that's a clue that you're looking for an angle measure, not a side length. And now to find y, I know that x and y are supplements, and so is angle R and U. So if it asks you to write something algebraic, you could show that R plus U, so U is 80, R is the y, and it's going to equal 180. If it wants it something algebraic. If it's not asking you to write something with an algebraic expression or an equation, then all you would have had to have shown me is that you had to do 180 minus 80, and y equals 100 degrees. Now let's go on to part B. It's got diagonals drawn in there. Now, notice X up here, it's got the little degree symbol. It wants us to find the measure of this entire angle. But let's go ahead and let's do this in alphabetical order. Let's find A first. Notice A is a side length and it's congruent. ST is congruent to RU. So since RU is 12, so is ST. So A equals 12. And B is on the diagonal here. And I know that diagonals are bisected when it's a parallelogram. So B is going to equal 9. And now what I can do, in order to find X, I need to add these two angles together. 45 plus 35. That's going to give me 80 for this whole angle together. And I know that this angle, U plus R, are supplements. So in order to find X, which is angle R, I'm just going to do 180 minus 80, and I get 100 degrees for variable X. And now for Y, remember when something is a parallelogram, what we can do is show we have parallel sides. So this side is parallel to this one. And then I can use this diagonal as a transversal, which now creates angle Y is alternate interior to the 45. So angle Y is 45 degrees. So Y is 45, X was 100, and then A was 12 and B was 9. So for C, again, I could use my my parallelogram opposite sides theorem and show that RS is congruent to UT and UR is congruent to ST. So I'm going to solve two separate equations. So in order to find X, I'm going to set 4X equal to 8. And to find Y, I'm going to set 3Y plus 4 equal to 13. So let me go ahead and solve each one. Divide both sides by 4. X equals 2. Over here, subtract the 4. 3Y equals 9. Divide by 3. And Y equals 3. Okay, so here it says to find the perimeter of parallelogram PINE. So let me go ahead and draw a parallelogram. I'm going to label it PINE. And they told me the length of PI was 12. The length of IN is 8. Now, I know when something is a parallelogram, we just learned that opposite sides are congruent. So if PI is 12, so is EN. And if IN is 8, PE is also 8. And whenever you find the perimeter of any figure, all you need to do is add up all the sides. So in order to get the perimeter, I'm going to add 8 plus 8 plus 12 plus 12, which will give me 40. So the perimeter of parallelogram PINE is equal to 40 units. If it would have had inches, you would say 40 inches. But whenever any units are not given, then you could just put units. Okay, so the next one wants us to write a 2-column proof. So again, statement column and our reasons. So state the given that A, B, C, D, and G, D, E, F are parallelograms. And if you don't want to write out this whole big word, you could just put a picture of a parallelogram, and this is given. So I've got this parallelogram over here, the ABCD, and then this one right here. They want me to show that angle B and F are congruent. So an angle from each one. So the first thing I'm going to do is I'm going to use one of the theorems that I just covered. And because I'm trying to show some angles are congruent, the theorem I'm going to use is the parallelogram opposite angles theorem. Because what I can state is that this angle here, this angle B, is congruent to this angle here. And I can't just call it D. I have to use 3 letters, and I'm going to call it CDA, or I could call it ADC, just as long as D is in the middle. And then I can also show in the pink parallelogram that angle F is congruent to angle EDG. And that's my next statement. And my reason is the parallelogram opposite angles theorem. So for the purple one, it'll be angle CDA is congruent to angle B, and for the pink one, EDG is congruent to angle F. Now, if you want to name angle B and F with 3 letters, you can, but because there's only one angle B and one angle F, I can get away with naming it with 1 letter. And this reason is the parallelogram opposite angles theorem. Now, if you forget the name, then you can write what this theorem states in the if-then form. So the other option would be to restate it, and you would have to state that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So either way, you either give me the name or give me what it states in if-then form. So now, if you notice that since F is congruent to EDG, and if you think about it, these angles right here, these are vertical angles. And then I can do a substitution. So my next statement is going to be to name those vertical angles. So I'm going to state that angle CDA is congruent to angle EDG. So this was the purple one. And this was the pink one. And if you notice, they're right up above here. So now that since these two are congruent to each other, I could state that these two are congruent. And that would be substitution. Now, this reason here for number 3 is your vertical angles congruence theorem. And you can abbreviate that as VAT. But if you want to write it out, it's vertical angles congruence theorem. But we use it so much, we can just use the acronym VAT. And then the last step is going to be angle B congruent to angle F, and we're using substitution. Here we go. I'm going to add in a picture of a graph. Okay, so step number 1, graph the vertices. So I'm going to graph W, X, and Z. We're looking for Y. So let's graph W. W is -1, -3. And label it. And then X is -3, +2. And Z is +4, -4. We're looking for Y. Now, it's very important that you pay attention, and when you connect your points, it needs to go into that order. So right now, we have W connected to X, but I don't have my Y. So if you think about it, Y is going to be somewhere over in this area. So let's go ahead, and the way that we're going to do this is we're going to find the slope. So step number 2 is to find the slope of WX. Because remember, when you have a parallelogram, these opposite sides need to be parallel. So I'm going to go ahead and calculate the slope of WX. So remember, your W order pair was -1, -3, and then X was the order pair -3, +2. So I'm going to plug it into the slope formula. So 2 minus negative, this should be -3, sorry, -3 here. So -1, -3 is W. I copied down the wrong point. Okay, so then -2 minus -3 over, and remember it's always Y on top and X on the bottom, then -3 minus -1, which gives me 5 over -2. So I have a slope of -5 over 2. Step 3, we're going to start at Z, which is the order pair 4, -4. And then what I'm going to do is I am going to take the slope I just calculated. So I'm going to rise and run using this slope, the -5 over 2. And I'm going to go ahead and plot my next point. So I'm going to move it to get to Y. So I'm going to be plotting a point for Y. And I'm going to go 5 up from Z, 5 up and 2 to the left from point Z. So let's try it. So if I go 5 up, let me erase the pink. So I'm going to go up 5. 1, 2, 3, 4, 5. And then I'm going to go 2 to the left. And my new point for Y is going to be the order pair 2 comma 1. So if I connect this, it creates my parallelogram. And it went in the appropriate order. Remember, it was W, X, Y, Z, and it went in that order. So I did place Y in the right spot. Now, what you can do, and this is my new Y, 2 comma 1. In order to check it, what you can do, this is to check that you did it right. You can find the slope, or the slopes of XY and WZ to verify that they're parallel. Okay, so what we would do is to find the slope of XY, I take the new order pair plus the X from the beginning, do the slope formula. So 1 minus 2, 2 minus negative 3, negative 1 over 5, so negative 1/5. And then WZ, its slope will be negative 4 minus negative 3, 4 minus negative 1, negative 1 over 5, so negative 1/5. I got the same slope. I can tell that those sides are parallel. Now, if you've got a nice, neat graph, you could also count the slope, the rise and the run, just to make sure. So this last step is optional. If you would have rather just counted the rise and the run, so like, for example, go up 1 and then 5 over, up 1, 5 over, and then the same thing over here. Check that these are parallel. If they're not, then you've got the wrong Y. So that's a way to check it. Now, in the homework, they're going to ask you to find the intersection of the diagonals. So if I draw in diagonals, they want us to find the point of intersection. And really, all you need to do is find the midpoint of one of the diagonals. And that'll give you the point of intersection. So if you were uncertain about your Y order pair, then I would have done diagonal XZ. And X was negative 3, 2. Z was 4, negative 4. So negative 3 plus 4, divide by 2. 2 plus negative 4, divide by 2. 1/2. Negative 2 over 2. So 1/2, negative 1 is the point of intersection of the diagonals. And mine's a little off. So this is why it's always better to actually do the calculation, because if your graph is a little off, so it should go right through here. So it should be 1/2 and negative 1. So it should have been like right around there. So this is why I would do the midpoint formula, because more than likely it's going to be a fraction on the quiz. These are the problems that need work. 2, 3, 4, 7, 8, 9, 10, 11, 12, and 13.